So, as Julie said, I've been here for 16 years, and I am the director of the Human-Centered Data Science Lab, and I have been a very excited participant of HCDE for many years, since right after it changed its name, and I love this department. I love the combination of human-centeredness and design and technology and data science, and now artificial intelligence, which has come back. I actually started my career in computer science way back as a college student by working in artificial intelligence. My first language was actually Lisp, if anybody remembers that, back from the dawn of time. And it's been kind of interesting to see this sort of this long up and down history of artificial intelligence. So I do like talks that are more a conversation. So please feel free to raise your hand and let me know if you have a question about anything I talk about, and you can ask me anything. If I don't like it, I just won't answer. So feel free. All right. So I'm assuming that all of you are students in HCDE, is that correct? Is anybody not a student or a faculty member or staff in HCDE? Oh, okay. Where are you? Can you shout out where you're from? Our school, CS. Okay, CS, great. Anybody else? Oh, awesome. All right. Anybody else?
Emerson Technology Innovation under Foster and College of Engineering.
Oh, great. That's wonderful. Well, I'm glad to see people from both CSE and from Foster here, because my PhD was in computer science, and now I've been working a lot with people in Foster because I am the co-founder of a startup, which is actually doing really well. I'm super happy about it, and it's a ton of work, but it's amazing. And so I'm doing my best to learn about business, although I'm sure you all know more than I do. So maybe if I talk about my startup, you can correct me. All right? Okay. Let's talk about why people must come first in artificial intelligence, which we are seeing everywhere today. We're seeing artificial intelligence. We all have to focus on that. That's the big thing. And I agree, it's incredibly important. It's changing things. But we cannot just let it happen. We have to participate, and most importantly, we have to make it human-centered. And I hope that at the end of this talk, I can convince those of you who are not already convinced that people must come first in all design of artificial intelligence. So I first titled this talk A Short History of Human-Centered AI. So I'm going to start with some stories from a while back. So this was from 2018. There was a hospital in Arkansas that decided, we're going to automate. We're going to use an automated system to decide who gets health care, all right? We want to determine how many hours of home care disabled people get. And by automating it, we're going to eliminate waste. We're going to be more efficient. We're not going to have the problems of biased humans making decisions. Okay, so one day, Tammy Dobbs, she had cerebral palsy, and she'd been receiving help with bathing, eating, and getting out of bed. She had her care hours slashed from 56 hours a week to 32 hours per week. And there was no explanation, no warning, just a letter that said, this is what you're going to get. When she asked why, she was told, oh, the algorithm decided. And she said, well, can I see how the algorithm works? And they said, oh, no, that's proprietary. When she asked to appeal, they said, oh, there's no way to appeal a decision that was made by the algorithm. So what makes this story relevant from a technical perspective, because I'm interested not just in the policy and business ends, which are, of course, very important, but I'm interested in it as a person who writes software. So I'm writing AI software right now for my startup, and I want to make sure that it is ethical. So what makes this story relevant is that the algorithm was not wrong, all right? It did not have a bug. It didn't crash. It executed what the programmers optimized for. And what was the issue? They optimized for, can anybody guess? By now, you should all know. What do you think the programmers optimized this algorithm for? Yes, reducing costs, all right? It didn't talk about improving care. It didn't talk about individual circumstances. So the algorithm just saw TAMI as a collection of data points, diagnosis codes, age, prior utilization. It couldn't see that cerebral palsy affects everybody differently. I mean, from people who are severely disabled to people who are, pretty much functional. And it couldn't see that Tammy had been stable because of the care she was receiving. It didn't see her as a human being. So this is the difference between technically correct and human-centered. And that's why I'm here talking to you today. So I have been in this, as I said, I've been in this field for a long time, probably longer than 30 years. Because if I do add up my math, it's like 1980s, and now it's 1925, so maybe more like 40. But I did take some time off, so we're not going to talk about that today. So I got a PhD in computer science from UC Berkeley. I have a minor in statistics, and my bachelor's was in mathematics from Caltech. And when I started out, there were no computer science degrees at Caltech. I was really interested in it, but they said, oh, this is probably just a fad. How many of you have heard that human-centeredness is just a fad, that it's not a real discipline? I don't know if you have, but that has happened to me many times. So yeah, and then one professor even told me, only failed mathematicians go into computer science. Why are you doing that? And I said, well, I thought to myself, I didn't dare say this out loud because I was just an undergraduate, but I thought, I think computer science has a future. And instead I said, well, I really love computer science. I love the applications of math to computer science. So I started out working in industry. Once I graduated, I did combinatorial optimization, these statistical algorithms, machine learning, artificial intelligence, image processing, and character recognition. And I just enjoyed it. I would solve these problems, these very technical problems, by doing very mathematical algorithms, and I had just a lot of fun with it. But then I moved into government labs where I was still doing machine learning over scientific data, working on airflow across aircraft and spacecraft, and astrophysics and supernova data. And as I did this, I moved closer to the stakeholders and to the actual users of my software. And one of the things I discovered was that having a perfect algorithm was not enough. If the program was difficult to use, people just wouldn't use it. And it was kind of a shock to me, who came up in this sort of hardcore math and computer science view. And I realized that I had been missing maybe the most important part of computer science, and most likely the most difficult part, which is how can we make algorithms serve society and serve humans. And that just caused this huge shift in how I viewed my work and the world around me. And so I moved into human-centered data science, human-centered AI, and then eventually in 2010, I moved into academia because I realized that there were a lot of changes that needed to be made, and at the places I was working, I would say, we should do this. It's really important to bring human-centeredness into this. And they would say, oh, you have all these big ideas, Cecilia, but we got to get our job done. We got to do what we're funded to do. We got to do this. And so I realized that I was going to have more impact in academia rather than in industry. So, because it's all one thing to say, oh, your code is going to be running on, 5 billion computers, but if you don't have any say as to what's being done in that, that's not real impact. You have to be making the changes. You have to be in the room where the decisions are made, and you have to say, we have to build in human-centeredness from day one. So This has happened with AI as well. It's moved from specialized applications into systems that directly affect people's lives. Jobs, freedom, access to healthcare and housing. So I think we all should be fundamentally rethinking what it takes to do this job well. Technical excellence is necessary, but it's not sufficient. And we need to put people at the center. So today I want to talk about human-centered design isn't just a nice to have that you slap on at the end of building an AI or a data science program. It is essential, and it should be interwoven with all the software that's being built. When we build data-driven systems without putting people first, we don't just create bad products. We perpetuate inequality, erode trust, and cause real harm. All right, so I want to take a step back and talk about my first experiences with artificial intelligence. So I read this science fiction. I was a big science fiction reader. I still am, I guess. And so I read these books about Danny Dunn. This was back in the 60s and 70s. And has anybody read these? Okay, Cindy. Oh, and yeah, I'm sorry? Yes, exactly. I mean, I think this is a good book for basically anybody who's teaching today, because here's what happens, so Danny, this book came out in 1958, right? But long story short, he gets access to this computer of the time, which, by the way, the way it worked is you talked to the computer, it understood you, but it couldn't talk back. It spat out everything on reams of paper. So kind of the reverse of what we know today are difficult problems in computer science. But of course, these kids discover this, and what do they think? First of all, oh, this is something that can help us do our homework, and we don't have to do as much work when classes start. Have you heard that before? So anyway, it's a great story. I mean, I encourage people to read it just because it's really hilarious to see the history of what people thought about computing back in the day, and to also be aware that for people, so I'm a Gen Xer, but people who are boomers and who are Gen Xers think of artificial intelligence. They have the same mental models that they did back in the 50s and 60s, because your childhood memories and opinions are often the strongest ones. So that's why you see people saying, oh, artificial general intelligence is, 5 years around. And I'm like, okay, it might be coming, but it's not going to come through LLMs. I mean, I'm sorry. That is the wrong direction to go. But anyway, so I encourage the book. It'll give you some insight into older people's mental models. All right. So my lab is called the Human-Centered Data Science Lab, and so people always ask me, well, what is the relationship between data science and AI? So on the next page, I draw a Venn diagram of the two. So what do you think the Venn diagram should look like? Are they two completely separate circles? Do they have an intersection? Is one subsumed under the other, and if so, which one? What do you all think? What's the relationship? No, yes? Okay, if this were my class, you'd get an A. That's exactly right. The current iteration of AI, that's not the original artificial intelligence that I was learning back in the day, no. But now, generative AI it's based on very, very large data sets. It would not have arisen without all the scaffolding that data science has been providing for, the past 15 years, 20 years, perhaps. So all those algorithms that are being developed to deal with this massive amount of data and to ingest it rapidly, and the data centers that process it, all of that is what powers the current iteration of generative AI. So yeah, so my human-centered data science lab includes human-centered AI. It's not separate, and it's not, AI is not bigger than data science. So thank you. All right, so now I'm going to go back a little bit into the history of human-centered AI, because there's been a lot of really cool work that's been done in this area, and I hope that you can all look up some of the things that have been written. There was this great article that was done back in 2023, so this is really a historical article at this point, but they have a lot of important points that they bring up. All right, so they analyzed about 250 papers that were written before July 2022, and they tried to classify them using the typical social science 4 quadrants. And so they came up with these 4 areas, what they called explainable and interpretable AI, which of course we still have today, human-centered approaches to design and evaluate AI, and then human-AI collaboration, which is a big one today, and ethical AI. So these are all still pretty valid today. And then they divided the papers into this diagram, which I think is pretty interesting, because does anybody have any guesses as to how this has changed today? Were you going to say something, or no? No guesses. Well, yes. Yes, exactly. Very good point. Of course, all the circles are bigger because there's just a lot more work, but also there's a lot more overlap. They're not quite as separated anymore. All right. So Ben Schneiderman also wrote a really excellent book on human-centered AI, where he talks about artificial intelligence as a super tool, which I think is a really good perspective, because you don't want to think about it as, I mean, the term artificial intelligence is really, it's a bad name. They should have called it something else, because it makes people think that it will do a lot more, and that's why you get these AI summers where it's like, oh, it's going to solve everything. And then you get the AI winter where people say, AI isn't nearly as good as we thought it was going to be, and all of a sudden, everything crashes. And I've seen this happen like 4 times in my career. You know, this tremendous hype, and then boom, nothing. All right? So today is a little different, because I don't think it's going to be nothing. I think we're never going back to a nothing about AI, but I do think that there's going to be a big dip. And especially if more people like you who are interested in human-centeredness don't get out there and start working in these companies and having positions of authority in these companies to let them know that this is what needs to be changed. We need to have more human-centeredness. So Ben Schneiderman also has a framework that I think is really useful to look at. But I personally believe that defining human-centered AI is it's a good thing to try to do, but I think more important than a definition is thinking about what are we going to do, all right? What are we going to do in this field? And I've heard this again before. Everybody wanted to define computer science back in the 80s. What is computer science? Is it more math? Is it more engineering? Is it some of both? Oh, a field that has the term science in it isn't really science. I mean, I think I've heard all of this. But what I think is really important is we have artificial intelligence in the world today. We have the current version, these LLMs and what everybody is building on top of it. So which of these approaches are we going to take, and why, especially why is it important for us to think about human-centered AI, and why does it matter? So I'm going to be focusing not so much on the first 2, but on the second 2 in this talk. So I have 3 premises or theses that I hope to convince you of. I'm just checking the time to make sure I don't go too long. So first, the thinking about humans human issues in AI is necessary. That's an easy one, I think. I'm guessing probably everybody agrees. Does anybody not agree? Okay, great. I can go through that fast. Then number 2 is the human-centered approaches to AI actually make the technical work stronger. And this is something that I see a lot of pushback from people who start out in pure computer science. They say, oh, that's HCI is soft. You do it at the end. It's not important. And I hope to convince you that that is wrong, and I will show you quantitative evidence why that's the case. Then number 3 is finally, AI is human-centered whether we believe it or not. So all artificial intelligence, in my opinion, is human-centered, even if people think it's not. And so if you assume it's not, if you assume that you're not dealing with people, you're going to run into harm because you're not dealing with just, you're not dealing with points in a data set. You're dealing with human beings. All right, we'll start with the first. So this is an interesting, I'm sure all of you have been to airports and public buildings where they have somebody put in an automated system, and then people have stuck these little labels on top of it. And we wrote a paper on this, I think about 10 years ago, where we called it folk labeling, all right? Because what we wanted to show is that in any type of automation, there are these gaps that very often people need to fill it in. And we collected all this folk labeling, and there's our paper over there. If you Google folk labeling, if you're interested in it, you can download our paper. So that's sort of the mundane. But sometimes it's actually a much bigger problem, all right? And I'm just giving one example from one of the, there are many, many people who've done really important work in this area about the harms that automation has done. And so I'm just going to share one example from Virginia Eubanks, her book, Automating Inequality. So this was in Indiana, my former home state, and they said, oh, we are going to privatize and streamline government benefits. We're going to, save money, eliminate bias. We'll get to, fire staffers, so we'll save more money. Reduce taxes, yay! But then their system, which was produced by a company that had a proprietary algorithm, sent out these automated cancellations that nobody could appeal. And, despite them touting the Indiana government saying this is unbiased, it's going in a better direction, but sick people lost medication, and there was a 6-year-old girl who was denied Medicaid benefits for failure to cooperate. What that meant is this 6-year-old girl didn't respond to a letter, an automated letter, and her parents couldn't appeal it. All right, and she died. I mean, so it was billed as an attempt to save taxpayer dollars and prevent fraud, but not only did it cause a huge amount of human suffering, it ended up costing the state far more than it saved. So many lawsuits. So many lawsuits. So although there are opportunities for automated decision-making to improve things, you have to be really, really careful. I'm going to talk later about the problem with automation bias, all right? But right now, just know there are so many problems with it. All right, so now let's take a step back and again look into the history of software development. So this is also an old survey that I've talked to people now, and it's still true. If you are a software developer, or a designer, a UX designer at a large company, and you discover that your company is building something that you realize is unethical, well, the first thing is, do developers have an obligation to consider ethics? And, most of us are good people. We don't want to build unethical stuff. So most people said, yeah, we do. We have to think about it. But then, well, what would you do if your boss told you to write software for an unethical purpose? And now the majority is a little smaller. Okay, 60% said, well, no. But then a larger group said, well, it depends on what it is. Okay, you're getting a little wishy-washy here, people. And then finally, they totally punt. They say, who is ultimately most responsible for code that accomplishes something unethical? The developer who wrote it, or the upper management of the company or the organization? And they all say, oh, it's the upper management. We can't do this. We can't keep going like this, because upper management, maybe I shouldn't say this if this is being recorded, but you can't count on upper management putting ethics first, because they have an obligation to their shareholders to just maximize profit. So you, as a good human being, need to figure out a way to speak up, let people know what's going on, and make sure that ethics is considered in your organization. When we get to the next section, I'll show you it turns out that's actually better for the company, too. So I'm going to give you some weapons to go, and maybe I shouldn't say weapons either. I'll give you some tools that you can use when you go and talk to your bosses, when you go out into the working world. All right, I do want to talk about automation bias, because very often I've seen people say, well, yeah, we're gonna add the ability to talk to a human in all of our systems. We're going to just make a suggestion. So this software will make a suggestion to the person. Well, again, there's been lots of studies on this. You know, there's software that you give it to a judge and say, this is the recommended sentence for this person. And of course, it's based on biased data, which has all sorts of racial and ethnic biases in it. And what happens is the judge, no matter how they want to be fair, will look at what the computer says, and they have this mental model in their head. This algorithm is a lot smarter than me. It's going to give me a good result, and I'm going to just follow it. It's easier. It's the path of least resistance. Besides, I'm tired. I haven't had lunch. You know, so there's this incredible overdependence on machine that cuts across all fields. And it's a common source of errors, and it can actually be deadly. So I'm involved in aviation, and one really good example is there was a flight from Miami to Cali, Colombia. This was back in 1995. They had an autopilot because aviation has embraced automation much sooner than everybody else, and and they keyed in something wrong because of autocorrect, right? They typed in RO, and the autopilot said it was Romeo, but it was really supposed to be Rosso, and so it took them in a completely different direction. All right, so the way they were supposed to go was between high mountains. It was at night, so they couldn't see the terrain, and they were on an instrument plan, so it was cloudy as well. And Romeo was off in this direction, took them straight into a mountain. 159 people died. All right, and that was, even though the human had the ability to override the automation, they just didn't do it. All right. Okay, so that's why it's important. Now, human-centered approaches to AI actually make the technical work stronger. So I'm giving one example from my personal experience because I know it the best, but there are many, many more of these. So I was hired in 2005 to solve a big data problem. So this is back when big data and data science was very new. And so they had a problem. They'd already hired 2 teams of really smart computer scientists, and their software was failing. It just wasn't working. And so then I came in here, solve all our problems, Cecilia, no pressure. So it was just me, and I said, well, I'm going to take a human-centered approach. I'm going to use social science techniques like ethnography and qualitative analysis, and luckily, the leaders of the project, I mean, I said, I won't take the job unless you let me do it the way I want to, and then I explained why. And they said, yes, we'll support you. So they did. But everybody on the project was like, Cecilia, why don't you just write code? What are you doing? I was the only woman on the project. I was the only person whose PhD was not in physics. All right, these were all astrophysicists. Anybody who's worked with physics PhDs knows the only reason any of us don't have a PhD in physics is because we're not smart enough. Because if we were smarter, we would have gotten a PhD in physics. So here I came. I remember I had this really great job at NASA, and I moved here to LBL. I remember I cried every day saying, why did I quit my other job? Because these... But I'll just skip ahead and give a spoiler alert. The good news is that if you're in a hostile environment where nobody believes in you and then you solve their problem when nobody else could, suddenly they become your advocates. And they become your advocates for life because they remember that. And that's what happened to me because I did solve this problem through a human-centered approach. So there were these four techniques, and each one of them made a difference in the software and improved it. Because of time limitations, I'm not going to go through any of them except let's see. I'm going to talk only about example 2, and I'll do that really briefly. But I do want to say that the first 2 approaches are purely technical, involving new algorithms that I wrote and implemented. And the second 2 were more social science-based, where I studied the humans on the project and came up with a human-centered approach that was all social science. Okay? But they all contributed to the ultimate success of the software. So they had this problem that was, back in the day, all right, they had all these stellar images, all right, where they took images of the sky, and it was 80 gigabytes of image data that they collected every night. And in 2005, this was a huge, overwhelming number. Processing that data took 12 hours on a supercomputer. You know, I think all we could afford in the project was 90 nodes, right? So it was much smaller scale than today, but back then it was at the limits, the cutting edge. And then that was processed nightly via image registration and subtraction, which I will show you in the next slide. And out of 600,000 potential supernova, a supernova is an exploding star that was being used by this collaboration to understand a grand challenge problem in astrophysics, which is the universe, what is the rate of expansion of the universe? And only 10 of those are potential supernovae. So they needed an algorithm to screen these out. So this is machine learning, all right? So anyway, to just give you a quick idea what it was like, this is a very simple, oversimplified version. So the image over there on the far, that's on your far left, that is a co-added set of images of a galaxy. So all of these images of the galaxy put together. And then the one in the middle is, the telescope has just found it last night, so it's that same galaxy. And then you subtract them, and what you get is that nice round image there, which is a supernova, an exploding star that's so bright, it actually rivals the light of the entire galaxy. I mean, this was a really cool project to work on. So that's what you want. That's a definite positive. But then on the bottom, you have an image of a star on the left, and then the same star over in the middle. But you see, it's near the edge of the image that was taken by the telescope. So that led to a bad subtraction because it was misaligned. Instead, you get this bright object here that's sticking out like this. All right, the C-shaped object. Now, okay, so what's interesting is that the physicists at the time did not realize that you could, well, okay, I'm just going to skip ahead. So I added two new features to this pipeline, and came up with a way to identify these features and then inserted them into the pipeline. All right, and it turned out that it found these good candidates, and what's more, the performance was incredibly fast. All right, so the reason why this technical approach is human-centered is because I came into the group and I said, you know what? I think we can use Fourier contradescriptor algorithms to solve this problem, because you can have a shape detection feature in your algorithm. And they said, as soon as I said Fourier, they all said, oh, we are using too much time already. We cannot add a Fourier transform into our pipeline. Cecilia, you are just not very smart. You're showing that your lack of physics background is coming up. And I said, wait, you know, first of all, this is order n, it's linear time and in the number of pixels, and I think I can come up with a constant time algorithm. So something really, really fast. And so they said, okay. And so I implemented it and put it in. They clearly didn't believe it. But then once I put it in, there was no increase in the running time. It was not negligible. And we had a 41% reduction in false positives. So why it's human-centered is because I was actually going against what the scientists were saying. So if they listed a requirements document for me, none of it would say, you know, write a Fourier contradescriptor tool to solve this problem. And this is why things like ethnography and qualitative analysis are so powerful. Actually sitting down with stakeholders, you can see the real issues, not just what they tell you. Because very often it's the unknown unknowns which are hardest to discover. Okay, so after all these four, and I have a story for all of these, but in the end, this human-centered AI approach in these 4 different areas led to, so when I started the project, there were 6 to 8 people, 6 to 8 postdocs, who were working 4 hours a day, doing all this grunt work, looking through these images, because they had to look through 1,000 images a day. It was a real pain. And after this, it was 90% labor savings. You could not automate the entire process. There were still some, AI is not 100%. There's still some things that slip through and that you need a human to look at. And, but that only took one person working 1 hour a day. So 90% labor savings, all right? And so the next thing that people always ask is, oh, did you put all these postdocs out of work with your AI algorithms, Cecilia? And I said, no, because what I did was I enabled these postdocs to do what they really wanted to do, which was science. They didn't want to be grunt workers looking at all these images. They wanted to write science papers. And so here you have, so I joined the project in 2005, and you can see how they started to discover supernova right after that. And more importantly, the publications went from 0 to 10 important publications that they could use for their careers going forward. But this argument here, the tasks and the FTE, that's what I used to talk to the Department of Energy and get them to fund a human-centered data science project with, you know, multi-million-dollar line of funding, because what they cared about was saving money. So you see, it makes it better. So you can tell your bosses, you'll save money and have better results. All right. And just from being human-centered. And now this is probably my ultimate favorite slide. Our principal investigator, Saul Perlmutter, was awarded the 2011 Nobel Prize in Physics for this work. And I'm not saying that, you know, it was all his idea. It wasn't me. But he did say when he was awarded the prize, he said, well, it's really a team effort, and he named people who are on the team, and he named me. And that's the closest I will ever get to a Nobel Prize, so I will take it. All right, finally, I'm going to say that AI is human-centered, whether we believe it or not. So people are in there. So, you know, whether we know that it's human-centered or whether humans are just interwoven in there, they are, for better or for worse. And that's because it is, you know, part of data science. You know, it's often presented as this clean and impersonal sequence of computational operations. Unbiased. Automation is unbiased. But really, all the data that we have on this planet has human touches in it. All right? People touch the data at just about every step. And again, to keep this talk from going too long, I'm going to just very briefly discuss these 5 places of human intervention. I'm going to give a couple examples. So when somebody discovers a data set and decides to use it, even if, I mean, very often, a lot of the data, so for example, the LLMs today use human-generated text. You know, as a matter of fact, there's all these lawsuits going on now where people's books, including my 3 books, were scraped by Anthropic to train their AI, all right? And, you know, probably by all the other AI companies too, although the others haven't admitted it yet. So what we said, our human, you know, when the LLM gives you back an answer, it's building on, you know, the backs of billions of humans. But what's interesting to me is not just LLMs, but also something as abstract as astronomy data, right? You think that the images from the stars they're so far away from humans, right? But when I created a database for the supernova factory, and the astrophysicist told me, you know, when I was building one table that had galaxies and it was galaxy images and galaxy classification. And they said, make sure you write down the name of the person who classified it. And I said, well, why? The classification is, you know, it's a spiral galaxy, it's a flocculent galaxy, it's this, it's that. I mean, what does a human have to do? And they said, well, there's this one senior scientist who always classifies the galaxies differently than everybody else, but he's so senior and important that nobody can tell him that he's wrong. So we would just like to know. We're not saying change the database. We're saying just tell us if he was the one who classified it. So even in that data set, you needed to have the name of the human in there. And I would think that's one of the furthest away data sets that you would imagine is touched by humans, and yet it still was. And there's others, too, that you wouldn't think. So for example, if there's established color charts that are used to describe the appearance of Earth samples. So you collect samples of Earth, and then a human classifies them according to these established color charts, all right? And this is also done classifying species in biology. So the goal is to reduce this messy data, because data is messy. And you put it into this straightforward classes that are represented by labels and columns in a database. And this is what we call the design of data. And it takes many, many forms. But the point is, it's touched by a human. So all data has humans in it. I don't know whether it would be called human-centered, but it is human-infused. All right. So hopefully I have convinced you of these 3 points. And so now I'm just going to wrap up in the last few minutes. So the next question I said is, rather than defining it, how do we build human-centered AI? What do we do here at this university and other organizations? So these are some basic principles that I think anybody who's building an algorithm should think about. Don't start with what you can do. Oh, I came up with a new algorithm that's really cool. Start with a human problem. Go to the stakeholders first and listen to them. Also, representation matters. You know, there's famous stories about how the first, or many, even today, facial recognition systems don't recognize dark-skinned people as well as light-skinned people. And that was because there were no dark-skinned people in the labs building it. I believe very strongly that explainability is not optional. If you build a system, you can't just get away with saying, oh, it's proprietary. People have to understand how it works. Additionally, context is not noise, not never, but it's not noise, it's the signal. You need to think about the societal context that you're building your algorithm in. And yes, it's a little harder, but you'll have a better tool later. Finally, deploy with humility. Because, you know, we all make mistakes. We're all human. I mean, this is something I've learned from my many years working in industry and government labs and now in academia. I make lots of mistakes. And everybody I know, smart people, good, hardworking people, make mistakes. And the important thing is to be able to admit when you're wrong and say, this is what I'll do to fix it. So, okay, I want to give you at least a couple minutes for questions. So I want to close with how to teach human-centered AI. So this is something that I do in all my classrooms. I talk about human-centered thinking from the beginning. I talk about ethics from the beginning. I do not have a separate lecture on ethics. Ethics is included in every single lecture. It's not that I'm as expert as an ethicist who is a professional, and that is an important field, but it's just like we can all do addition even if we're not, you know, PhDs in mathematics. It's something we need to know. We need to have basic literacy in ethics and human-centered AI and in understanding what can be done in this field, because it's everywhere, and we need to understand that. All right. And I'm going to just finally close with something I just read, that if you're looking for a job after you graduate, it turns out that human-centered AI jobs are going up like crazy. If you see something called a forward deployed engineer, I read the definition of this. I said, oh, wait a minute. This is just human-centered AI that some company grabbed and said they started it. No, this is something we've been doing in academia for years. And so if you want to go out there and be ahead of everybody else who's been laid off from the tech industry, have a specialty in human-centered AI. So this is why I think this department is so great, because it does teach this. So those of you who are in other departments, try to take a class in HCDE. I think it will benefit you when you go out on the job market. And this slide has some great resources. You'll have access to the slides, so you don't have to copy them down. All right, I'm finished with 1 minute left. So thank you all for coming.